Hello and welcome back to another quality analysis video. So today we're taking a look at cyclomatic complexity, and as its name suggests, what cyclomatic complexity basically does is that it measures the complexity value of a code. So the lower the value of cyclomatic complexity for any piece of code, the better it is for a programmer. So let's get started. There are two main things from which we were going to be calculating cyclomatic complexity. First of all, we have flowcharts, like the one on the left, and secondly, we have code. So from these two things, we can calculate a value for cyclomatic complexity. Next, there are two main formulas for calculating the complexity of anything. And the first one that we're going to be seeing is here. So as you can see, I've written m equal to e minus n plus 2 into p. So here m is basically equal to our cyclomatic complexity. And then our e is equal to the number of edges. N is equal to the number of nodes, and P, I'm going to say that it's going to equal to the number of endpoints. But the thing about this formula here is that you're going to find variations of it, where some people will say that P is the number of cycles, and you'll hear other stuff too. But in my experience, I've seen that saying P is the number of endpoints, it makes the calculation simpler. So this is what each of the letters in our formula represent. So let's get started. Here is our first flowchart. So what you're going to do is, at first you're going to calculate the number of edges. So an edge is basically the straight lines that you can see here. Wait, I'm gonna mark that in blue. So this entire part here is an edge, and then we have another edge here, like so. So these are your number of edges, and you're going to have to count them. And the ones that I'm marking in red are your nodes. For example, not that one. For example, this here is your node, and yeah, that's a node too. So count the number of edges and count your number of nodes, and then we'll be well on our way to calculating the value. So in this flowchart, we have 1, 2, 3, 4, 5, 6, 7. We have the number of edges is equal to 7. Our number of nodes is equal to 1, 2, 3, 4, 5, 6, 7. That's also equal to 7. And now for our number of endpoints. So one thing you should know is that an endpoint in a flowchart is the node, wait, give me a second here, is the node which has no emitted edges. So what that basically means is that any node in your flowchart which doesn't have an arrow coming out of it is considered an endpoint. It won't have any arrow coming out of it. Alright, so if you take a look at all the nodes in our diagram here, you'll see that there is only one node which has no arrow coming out of it, and it's this node right here. Print ABC is our finishing node, our end node, right? So I'm just gonna mark that in purple. That's our end node. So the number of end nodes we have in this diagram is equal to 1. So P is equal to 1. So now we can calculate our value for M, and here we go. M is equal to 7 minus 7 plus 2 into 1, 2 into P. Therefore, M is equal to 2. And that's our value for cyclomatic complexity from this flowchart. And now let's move on to the code. So let's go here. Alright then. So we've looked at how to calculate the cyclomatic complexity from a flowchart with our m equal to E minus N plus 2 into P formula. Now we have a simpler formula to calculate cyclomatic complexity directly from code. So when applying this formula, you don't need to, draw the flowchart for the code. The formula is cyclomatic complexity. Cyclomatic complexity is equal to the number of regions plus 1. Alright, so you can use that to calculate cyclomatic complexity directly from a piece of code. So what is a region in a piece of code? Put simply, a region is any statement that includes if, else if, case, for, while, or do while. Alright, so these 6 statements identify a region in any piece of code. Now notice that there is no end if here, there is no just else here. We have else if and we have if. So you have to be careful of what you're counting as a region. So let's get started for our left piece of code. For the left one, we have a total of, let's see how many. I'm going to be marking the regions in red. So here is one if, and we don't have any other else if, case, for, while, do while statement in this code. So the number of regions here is equal to 1. And then our cyclomatic complexity is equal to 1 plus 1, which is equal to 2. And that is our answer. Okay, now for the right piece of code. We're going to just be applying the same procedure here, no change at all. And I'm going to be marking the values in green. So the regions in green, sorry. So here we have our first one, this while statement here. And then there's an if here, which makes 2. And now notice that we're not going to count the switch statements. We're going to count all of the case statements. So here is your case, and here's another one. Alright, and it looks like we don't have anything else. We have one while, one if, and 2 cases. So that makes for a total of 4 regions for this piece of code. 4, and our cyclomatic complexity is equal to 4 plus 1, which is equal to 5. So among these 2 pieces of code, this code is better. The left code is better because C value is lower. Alright, because it's simpler, it's less complex, the code on the left is better. And there is our tutorial on calculating cyclomatic complexity. Thank you so much.